Hi, I'm happy to have you back here, and we will start as usual with a math puzzle. The puzzle today is about this math teacher is explaining something here on the board, and is asking if A is a digit between 1 and 9, and you have A plus AA plus A plus A plus A equals 10 exponent 3. Can you calculate A? This is the question of the math puzzle today. Try to figure it out, and after the lesson we will get back and find the solution. Alright, and this is the chapter we're going to work is chapter 3, graphs and functions, and we will see section 3.2, introduction to functions today. The objective is to define, the first objective, to define relation, domain, and range. A little bit of vocabulary. The set of order pairs is also called a relation. So if you have any order pair, there's a relation there. The domain of the relation is the set of x coordinates, and the range of this relation is the set of y coordinates. And very simple example here. If we have this set of order pairs, the domain is going to be all the x coordinates. So let's find out here the domain, all the x coordinates. Let me just. Okay. So we have 4, we have -4, we have 2, and we have 10. So all these x coordinates here are part of the domain, and the range is the y coordinates. We can write down here 9, and we don't need to repeat, right? 9, 9, and 3. And -5. Okay, pretty simple. Now let's see another example. It's slightly different because now we have the domain, the input are animals, and the output is the lifespan. Is an input and output. The domain is going to be the x, which is the left column, the inputs, and the range is going to be the y coordinates, so the y output. So let's write down here the domain. We're going to write here all the animals as the domain, like polar bear, cow, polar bear, cow, chimpanzee, and giraffe, gorilla, kangaroo, red fox. All this is the domain. And the range 20, 15, 10, and 7. 20, 15, 10, and 7. Okay? Just simple examples to understand what is domain and what is range. Second objective that we have here is to identify functions, and some relations, they are also functions. The function is a relation in which each first component is the order pairs correspondence to exactly one second component. Let's translate this, let's understand what it means. For each, basically what it means is for each x, you're going to have only one y. Let's see this example. Is this relation here a function? And let's check. We have one x, 4, and one y, right? We have one x, -4, one y. We have one x, different x, 2, only one y. And another x, 10, equals only one y. Can you find any value of x that is associated, is linked to more than one y? No, you cannot find, right? So that means yes, it is a function. Because for each x, you're gonna have the link, the connection, the association with only one y. And we can see this on a graph, how to check it out, how to identify this on a graph. If we have here, check this graph here, is this a function or not? We have x equals -2, y equals 1 here, see? For x equals -2, y equals 1. Now, for x equals 3, you're going to have y equals 2 and y equals -3. That means here you're going to have for one x, you will have 2 y's. That means this is not function. Okay, this one is not a function. The other example that we have here, let's check the same thing for each x, and for x here we will have 1 y, right? For this x here, x equals 0, we will have 1 y. For x equals 1, we will have y equals -3. For x equals 3, y equals 2. That means for each x, we will have one and only one y, and we can say yes, it is a function. Another example, now we have an equation, and tell me, what do you think? Is this a relation represented by the equation a function or not? What do you think? Y equals x squared minus 2x. Is this a function or not? The way we check it is we assume values for x. Try to find one value that you assume for x that you're going to find more than y. But actually for each value that you plug in, that you assume for x, you will find only one y, right? This is y equals 0. If x equals 1, you're going to have y equals 1 minus 2, -1. There's no value that I can think for x that I will find a couple or more than one value for y. That means yes, it's a function. Let's check other example. What about this one? What do you think? And this is slightly different because you have x squared minus y squared equals 9. And let me show something here. This is the graph, the equation of a circle. If we assume, we can assume x equals, let's say x. We can solve this for x, right? It's going to be something like that. Square root of 9 minus y squared. If we have y equals 1 and y equals -1, this is going to be the same value for x. So we're going to have one x with 2 y's, right? Because 1 squared is equals to -1 squared. It's going to be like this. That x equals for y equals to 1, we're going to have x equals square root of 8, and for y equals -1, you will have x equals square root of 8 as well. For one value of x, we have two values of y. If we can find at least one situation that this happens, so we can say this is not a function. Next objective is using the vertical line test. This is a very interesting resource to check if a function, if a relation is a function, if you have the graph. So graphs can be used to determine if a relation is a function, and if no vertical line can be drawn so that it intersects a graph more than once, the graph is a function. Let's check how to apply, how to use it. And you can see the graph here as a relation, and it's a nice linear equation, but the question is this a function or not? What we're going to do, we will apply the vertical line test. We're going to try to draw a vertical line that intersects the graph in more than one point. If we cannot find any vertical line that intersects the graph in more than one point, that means this graph is a function. It is a function, because for each x is only one y. So if we cannot intercept in more than one point, yes, it is a function. That means yes, function. Next example. Try to apply the vertical line test here. Draw vertical lines and try to intersect this graph here in more than one point. And you can see you cannot, right? You cannot intersect this line in more than one point. No. That means yes, it is a function. Now, what about this one? This is pretty clear, right? We can draw a vertical line here, 2 points. We can draw another vertical line here, 2 intersections. We can draw another one right here, 2 intersections. That means not a function, not a function. Actually, if you have just one, if you can find just one vertical line that intersects in 2 points, is not a function. Since the graph of a linear equation is a line, all linear equations are functions. The exception is the ones whose graph are vertical lines. If you have a vertical line, of course, is not a function, and this is the only exception. All linear equations are functions except those of the form x equals c, which have the graph as a vertical line. Objective number 4, finding the domain and range of a function. If we have the graph, it's pretty easy to identify the domain and the range, as long as the graph has the limits here within the screen. We can see the limits. So let's check this one. Find the domain and range of the function graphed to the right. If we don't have arrows, that means the graph stops here. It starts, let's say, this is one of the endpoints, this is the other one of the endpoints. And to find the domain, we're going to find the x coordinates that are of the points included in this line. The points are all over here along the line, right? That means the x coordinates we can check here. The endpoint is this one, one of the endpoints, the lowest one, the lowest x coordinate, and this is the other endpoint with the highest, with the greatest x coordinate. That means the domain which is the x coordinates, can be represented right here. Let me represent on the x-axis. This is the domain. So this is going to be the domain on the x-axis. There's the whole interval between the endpoints of the graph, the line. From here, and this is 1, 2, 3, 4. And actually starts here on -1, -2, -3. Right? What about the range? The range we will check, we will find on the y-axis. So let me get another color. Starting, the lowest point is going to be this. The greatest, the highest one is this. And the range is going to be everything in between, including the endpoints. Representing using interval notation, and here is -1, -2, -3, -4, and here 1, 2. Domain. Using interval notation from -3 to 4, and range from -4 all the way up to 2. And another example, let's check this graph here. The domain and range are here already, but you can see the range, the domain is going to be the, if we have the arrows, now it's a little bit different because the arrows means the graph goes all the way to infinity. And in this case, in this example, the domain is going to be the whole x-axis. It's going to be from -infinity to infinity because of the arrows. See? Now the range. The range, there's a lower endpoint here, right? This is, we don't have any graph underneath this point, below this point. And we have the range also going all the way up to infinity because of the arrows. So we can write down the domain as -infinity to infinity, and the range is starting here on -2, inclusive, going all the way up to infinity. Next objective, using function notation. To denote that y is a function of x, then we can write y equals f of x. So the equations that we will use as functions, instead of y, we will apply, we're going to use this notation here, f of x. It's the most usual notation. Helpful hint, and this is just so you don't mix things up. Don't mix things up, please. Note that fx is a special symbol used to denote a function. This symbol fx is read f of x. It does not mean f times x. No, not f times x. Does not mix up things. So find each function value. If f of x equals 4x minus 1, find f of 2. And what you have to do here, very simply, is plugging in and making x equals 2. Then you're going to find f of 2 equals 4 times 2 minus 1, 4 times 2, 8, minus 1, 7. Okay? Now, next next example. And as you can see here, sometimes you can use different letter. F of x is the most usual notation, but you can use also g of x. Is a function as well, just a different name and different function. You make x equals, we want to find g of -3, so you make x equals -3, then we find g of -3 equals -3 squared minus 2 times -3, and this is going to be equal to -3 squared 9 minus negative with negative positive, 2 times 3, 6, 15. That's it. That's how we find the functional values, how to evaluate functions. And a new example, given g of x equals x squared minus 2x, it's kind of the same. Yes, find g is the same thing. Then write down the corresponding order pair. Okay, let's write down the order pair here. We want the order pair. What's going to be x? This is x. -3 is x. So -3. And which one is y here? The evaluation, the solution that we found by plugging in x is y. So it's 15. The order pair solution of this is x equals -3, y equals 15. A new example. Given the graph of the following functions, find each function by value by inspecting the graph. Okay, the first one is f of 5. That means x equals 5. Find x equals 5 on the graph. So we have 1, 2, 3, 4, 5. And 5, we have a point. We're going to have a point, I think, here. Right? And this, the y is going to be 1, 2, 3, 4, 5, 6, 7. 7. If f of x equals 5 is going to be 7. F of 4, and 4 is here. So let's check the point on the graph for x equals 4. The y is going to be 3. So f of 4 equals 3. F of -5. All right, -5. 1, 2, 3, 4. -5. -5 is here. Let me write a nice 5. And the answer is the point on the graph. -1, right? -1 is y, -1. Now f of x equals -6. -6 is here. The intersection with the graph is, and then we will find the y coordinate is, or f of -6 is -1, -2, 3, 4, 5, -6. Right? -6, -6. Yes. Okay, that's how we evaluate the value of the function using the graph, inspecting the graph. Now objective E, graph a linear function. A linear function is going to be a function with the following form. F of x equals m of x plus b. And this is going to be very helpful to this form here. It's called the slope intersect form. It's very helpful to graph the function because m is the slope, right? M is the slope, and b is the y-intercept. So if we have a linear function written on this form, then we can easily graph it. Okay, let's solve this example here. Graph the function f of x equals 3x minus 2. Well, we know that m is the slope. That means m equals 3. And the slope is rise over run. That means rise is 3 and run is 1. Okay? Another thing that we know is that b is the y-intercept. B is y-intercept, which is equals to -2. So let's go to the rectangular coordinate system, find y equals -2, which is here. This is the point, y equals -2. Now we're gonna run 1 unit. Run 1 unit to the right. This is run 1 unit. So run 1 unit and rise 3 units. 1, 2, 3. Rise 3. The next point, the second point, is going to be here, and now we are able to draw the graph. So connect the dots, connect the points, and this is going to be the function, the graph of the linear function that we are looking for, f of x equals 3x minus 2. Great! That's the end of section. We've been working now on section 3.2, sorry, section 3.2, yes. And let's find out if we can answer this puzzle here, this math puzzle. Think about it. A plus AA plus A plus A plus A equals 1000, or 10 exponent 3. You can try numbers. You can try 1, and then 2, and then 3, and check if they fit. Or you can calculate. One way of calculating it is you can factor out A times 111 plus 100 plus 11 plus 1 plus 1 plus 1 equals 1000, right? If you add, this is going to be 125. That means A equals 1000 divided by 125. If you do the math, you're gonna find A equals 8. So the answer here is going to be 888 plus 88 plus 8 plus 8 plus 8 equals 1000. And what's nice is this, you're going to have 8 numbers 8 to make 1000. Alright, thank you for watching this video, and hope to see you on next section.